Hey guys, welcome to Rain's Physics. Let's talk a little bit about intro to vectors. So when you're dealing with vectors, we are going to sum or add them together if they are in the same direction. As you see vector 1 and vector 2, we add them together. One's 10, one's 3, and we get 13 for the resultant vector. So when vectors are in the same direction, you will add them together. When vectors are in opposite directions, you're going to subtract them. So in this case, that 10 and 3, you subtract them and you end up getting 7 in the direction that it was the greater vector. So in this case, we have to the east or to the right, 10 was greater, and so the resultant vector is in that same direction. But you do subtract them when they're in opposite directions. Now, what if they are at right angles? So there's lots of things that we can do once we have determined right angles and we make angles out of vectors. The first thing that sticks out to your mind is probably going to be Pythagorean theorem. You see this in a couple of places. If you look here, I used 10 squared plus 3 squared, and I took the square root of that, and I got 10.44 meters. So that's how I did that. Using Pythagorean theorem, we can find the resulting vector if you've got two sides of that triangle. Now, because of that, you can also use trigonometric functions. And what I mean by that is if you know the two sides of a triangle, but you don't know the hypotenuse, you can use trigonometric functions if you have the angle to also solve for that. And that's where you get this tan of theta equals the opposite from the angle. And so if we go back real quick, I do apologize. If we go back, you can see that the opposite of the angle is going to be y, and the adjacent is going to be the x. We see down at the bottom, tangent of the angle is equal to y over x. And so that's how you use the tangent function. Now there's more than just a tangent function. There's also the sine and cosine function if you know the hypotenuse. You already know the resultant vector, but we want to break them into components. We want to know what was the vertical change or what was the horizontal change. This will become very important when we talk about projectiles. And so take a look down at the bottom. You see a plane and a truck. If the plane is flying at its angle above horizontal and that truck is kind of continuing on, they want to know what would the speed be for the truck to stay directly underneath the plane. And so you would solve for the horizontal component there, and because it's close to the angle, the x is horizontal, you would use cosine in this case. And so you would do 95 times the cosine of 20, and that would tell you what your speed the truck needs to be to stay underneath that plane directly. And so that's how you use these types of functions. Stay tuned for more practice problems on how to do these specific vectors. I hope that helps. Have a wonderful day.